Well, welcome to a quick toddfun.com autopsy. This is my cruise control component that basically has the cable on it to maintain your cruise for your throttle position. And I was working on my Jeep doing some general work, and the plastics are getting kind of old, and this little vacuum adapter that goes on here, which supplies the vacuum to the cruise control diaphragm mechanism here, it got knocked and broke off, and so that makes this completely useless. So why not do an autopsy? This is the cable side that goes to the throttle. It's just connected with a couple of bolts right here. We'll take those off. And on this side we have it's like got 4 wire connectors, and so we'll see the electronics in there. So this cap just comes off where the wire harness hooked on, and then this is essentially the electronics that are going to control how much vacuum the diaphragm gets. And it actually just pulls right out of there, and we'll see what's inside, and we'll look at this carefully in a minute. When you take those off, then this shield pulls back, and you can see there's a sort of a cotter key kind of mechanism. You got to pull that out, and that yanks out, and then the cable comes off, and you're left with just the box. And this is all trash now, because with that broken vacuum connector, this whole thing is trash. Actually, I pried all around here with a screwdriver, and actually kind of got a pliers in there, and I pried around that plastic, and this kind of pops off now. Might have to get a screwdriver to wedge it out of there. There we go. So, back plastic, it's all just plastic. There's a spring that pushes the diaphragm back out, and there's the diaphragm. And what that does is just basically, as a vacuum is generated, this gets sucked in, pulls on that cable, and the way the computer on the vehicle controls your speed is, it appears it has 3 solenoids with a little plug stopper on each one. There's 3 because if you look in there, I think I got a pointer here, you'll see that there's a chamber. There's 1, 2, 3 plastic chambers. Each one has a little bleed hole, big one, and then a medium one, and then a small one. And so by controlling which one of these solenoids is on, controls how much vacuum you generate in your diaphragm, how much vacuum you let into your diaphragm to suck your diaphragm back, and that sets your cruise speed. And I wouldn't doubt it could turn these on and off, fairly quickly to maintain some exact bleed ratio. And because the vehicle knows its speed, it knows how much to flutter these things on and off to keep that vacuum pulled just right for the speed. There's like little O-rings on it for sealing, and there's a little rubber tip that must plug it at the bottom so it can't bleed through until it pulls back. There's 4 connectors. I think it's kind of clear what's going on. This one right here will be a ground, because it actually seems to be common to all 3 solenoids, these coils. And then there looks like there's going to ground. There's going to be a diode, so a flyback diode, so that when these de-energize, the magnetic fields don't spike voltage back into your system, and that bleeds it off essentially backwards. Well, we might as well engage these. I mean, all you're going to have to do is apply 12 volts, because that's what your vehicle's doing, is pulsing, either full on 12 volts or pulsing 12 volts to these solenoids to open and close them to maintain that vacuum in your diaphragm. So let's hook it up to the bench power supply and actuate them just for fun. I got my power supply set to 12 volts, which is what a vehicle would run on. So there's the middle one. Yeah, that's right. And then the next one over is this guy over here. And as soon as I touch it, that engages. And then this one should be the last one over here. But you'll see, actually notice my my meter goes into constant current. And this isn't working because there's the flyback diode there that is actually, so when this coil de-energizes, it the energy will go backwards through that diode right there. And what that means is I got the leads wrong. Actually, it's not common cathode, it's common anode. So I'll have to make this work. I have to put the 12 volts on that common pin so that I'm not driving that flyback diode backwards. So now this third one should work. Yeah, so now the third one is working. And the other two will still work because you're still displaying voltage. Yep. Now, why is there a flyback diode for only this one coil? Because all of these would have the same problem. There should be a flyback diode for each of them for protection. So, let's see. It goes in like this. And, yeah, I don't know if you noticed, but you see those holes back in there. This one on this side is the biggest hole. And hence, that is going to be, it sits in this way, so that's this plunger. And so what basically I think is happening is they're only energizing this one 100%. And that it has the biggest hole, provides all the vacuum for that device. And hence, because this builds up a large magnetic field, when you disengage that magnetic field has to collapse, and that goes backwards through the diode. Now, that would mean that they chose not to put a flyback diode on these other two coils because, and it's not, they're not using this, because they probably only engage these ever so quickly, just to kind of like twiddle it at exactly the speed you want to go. You know, if you need a little, you do this one. If you need a little bit more, you do this one. But this one will be on probably all the time to try and get you up to that speed. And so there are no large magnetic fields build up in these two coils, and hence they didn't deem it necessary to throw that extra protection in there. Which would be my evaluation. So, well, that's about it. Hope you enjoyed the quick little teardown. Thanks for joining.